Today we learn the chapter 6, 8 part, which is calculation part. We will talk about the rule of integration. Integral. Integral is also called antiderivative. It is the inverse operation of derivative. Number, if you take integral, then take derivative, is going to be itself. The integral and the derivative are inverse to each other, just like addition, subtraction are inverse to each other. Addition, a number you add by 3, then you subtract 3. Addition, add 3. Subtraction, subtract 3 is still original number. A number you multiply by 2, then you divide it by 2 is still original number. So multiplication and division are inverse operation. And the function and the inverse function are inverse to each other. And it's going to be after composite function and the inverse function. After composite, it's an identity function. Then the two functions are inverse to each other. Composite equal identity function, which is f of f inverse of x equals I of x equals f inverse of f of x. Then the two we call inverse to each other, like 3 add negative 3 equal identity element 0 of addition equal negative 3 add 3. Then the two number we call additive inverse, also called opposite to each other, like 3 times 3 over 2 times 2 over 3 equals 1. 1 is the identity element of multiplication, then equal 2 over 3 times 3 over 2. Then the two we call multiplicative inverse to each other, also called reciprocal to each other. So the mathematics, we have such kind. So for the same thing, for calculus, you take derivative, then you take integral. It's going to be original one, f of x. If f of x take derivative, then take integral and still f of x. If f of x take integral and then take derivative, is still f of x. So derivative and the integral are inverse operations. So we call integral called antiderivative. So use this property, then we can talk about the integral of x to the power n dx, which is n plus 1 x to the power n plus 1 plus constant c, because this is a formula power rule of integral. And because this take derivative, become n plus 1 go from, and n plus 1 still there, and x to the power n plus 1 minus 1 is n, and c take derivative is 0, and this cancel is 1, and go back to x to the power n. So this take derivative, go back to this. So this take integral is this, because a number you take integral and get this, then take derivative is still original. That is the integral. So integral formula, x to the power n power rule. For constant term, integral of constant term, like k, if I say k, dx is going to be kx plus c. The reason, because this take derivative is going to be k. C take derivative is 0. So take derivative is go back to k. So k take integral is this. Is kx plus c. So here is the formula. And here use u, du, then ku plus c. And then there's power rule. Power rule. And the constant multiply rule, this k times f of u du, this k can factor out. Factor out. And for integral has a sum and difference rule. Derivative also has a sum difference rule. F prime plus g prime is take integral also have a sum. The two function add together or subtraction take integral is equal to each function take integral add together, sum or difference formula. And for e function take integral still e to the power u, because e take derivative is e to the power u is itself. So e function take integral still e to the power u. Ln u take derivative is 1 over u. So integral of 1 over u is ln u and plus c. And here u has to be put absolute value, because for ln function, this part need to be positive. If u is negative, you have to change to positive. So to put the absolute value. And this is this we call the fundamental theorem of calculus. This is also called definite integral from a to b. Is the same as after take integral and then put b and minus put a. I'll show you this by examples. And this one's average value of this function. This is because if a function take integral, there's another definition we call Riemann sum. Before we talk about antiderivative, integral and the derivative are inverse to each other, and so we can get those formulas. Now we are going to talk about the second concept of integral. The integral use Riemann sum, to talk about the integral. If here has a graph, and this graph function is f of x, and here is x, here is y. Y is the function value f of x. And then we partition this area under this function curve from a to b. We partition into n intervals. From a to b, partition into n equal subintervals. And those subintervals add together, the area is this area, and times the height. And each area we call delta x, and times the height at this point, f of xi. Like this is the x1, this, if I use midpoint for each interval, subinterval use midpoint. From a to b, b minus a, if you divide it by n intervals, and this we call delta x, n intervals, and each interval, the base, the length of the base is delta x, and the height is assumed like first interval we say f of x I, then until f of x n intervals, the height. And such area you add together, n interval add together, summation. I go from 1 to n. That's the area under area. Very close the area when if I say limit when n go infinite, when n go infinite, which is you partition into infinite intervals. So that's become this high and times the base. And this delta x is when n go infinite. This limit when n go infinite. Limit when n go infinite. Delta x become very, very small x. We call dx, difference of x. Difference between two x, very, very small. Very, very small difference called dx. And this is the base. This base is dx and times the height. Times the height. The height is the function value. If when they are very, very small, then it's going to be function value. So this part is going to be function value, height times the base dx, and that's the area. The area, and such areas, such infinite areas add together, and that's become the area under the function, under the curve. Add together. This when n go infinite, and such area add together. This one become continuous sum. This we call discrete sum, and go from 1, 2, 3, 4, 5, 6 until n it's infinite. That's what we call discrete sum, discrete number, discrete sum. Then when we go n go infinite, that's become continuous sum, and this is we call continuous sum. And sum go from the first number a, the last number b, from a to b. So this discrete sum become continuous sum, and that's become integral. So this one is going to be the area under this function. Is the height f of x times the base. Height times the base is the area of rectangle. Height times the base is the area of rectangle. And this area, add this area, add this area, continuous area, add together, continuous, add together, infinite rectangle, add together. And that's become the area under the curve, under the function. So this integral definition is also area. That's the second concept. First concept is antiderivative. Integral is the antiderivative. Second concept here, we talk about definite integral from a to b. The first concept, we use it for the infinite integral, and there's no bound, like just this, no bound, like f of x dx. And now this is we call definite integral, which have bound from a to b. And this is use Riemann sum. You can see it's area under the curve. Area under the curve. Now, next, we talk about the average value. Average value, it's you can see those values as different because different f of x. X is between a to b, and 1x have f of x. This height is different. So we are going to find average. So this is the area. If you divide it by the total base, this one, integral of a to b. This one, you divide it by the base. You figure out the area, and then you divide it by the base, and you will get height. And this height we call average value. Average. What is the average value? That means for every x, they are same height. And this average value times b minus a times this base is going to be equal the total area. So you always can find out a c, and then this this area, the red one, this rectangle area, and this point, this height is f average value, and you always can find a C between A and B such that this f of C times this height times this base is going to be rectangle area. Rectangle area is equal to this area under the curve. The two areas are equal. And this is going to be average value. So what is the average value? Is the area under the curve, which is integral from a to b f of x dx, is the area under the curve divided by b minus 8 divided by this base, this length, and you got this height, which for every x they have same height. So if this value, average value times b minus a, this average value times b minus a is going to be this rectangle area. And this rectangle area is equal to the area under the function curve. Equal. The two areas are equal. So that's what is average. What that average value means. Means for every x have the same height. It's average, same height. So here formula, average value of f over interval a to b is going to be integral a to b f of x dx divided by b minus 8. Area between two curves. This one is the area between two curves. It's going to be, if it here has one curve, is f of x. Another curve is g of x. And then you do from a to b, that is this area. Integral f of x from a to b dx. That's this area. Then you minus integral from a to b g of x dx, which is under g function, this area. Minus this integral. That's become integral between the two curves. And you can put together as integral a to b f of x minus g of x dx. You do f of x minus g of x, which is this, and times dx, and add those together, continuous sum. Add together, that is the area between two curves. So the formula for areas between two curves is integral a to b, the two function minus take integral dx. And the rest formula is going to be application formula. And we will learn in 6b, B part. A part is only calculation. We learn calculation formulas. And we will use into those application in B part. Now let's do the examples for the homework. The first question, integral 5x cubed dx. First of all, we use the constant multiplication rule. We can factor out this constant. This we also call scalar multiplication. This scalar factor out, and get integral s cubed dx. And this scalar 5 times this x cubed dx, take integral and use the power rule. Integral un du is equals u to the power n plus 1 over n plus 1 plus c. The reason because you take derivative, you go back to u to the power n. So you take an integral is going to be 3 plus 1, I get 4. And then 3 plus 1 get x to the power 4 and plus constant. Then you can check it. You take derivative. Take derivative and 4 go from. Cancel with the denominator 4. Then 4 minus 1. And you got 5x cubed. And then c take derivative is 0. So you go back to 5x cubed. So this take derivative is this. So this take integral 5x cubed, take integral will be this. They are antiderivative to inverse operation to each other. And the next one also use power rule. And first of all is the 4 is a scalar multiplication rule. Factor out 4. And integral t -3 dt. And 4 times this one and use the power rule. -3 add 1. Get -2, and t to the power -3 add 1 get -2 plus c. And here cancel, cancel, get -2, -2, t to the power -2, and plus c. And we don't leave answer with t to the power -2. We are requested to change to final answer. Use if you leave as a -2, it's not final answer. You move down to the denominator. Use negative exponent rule. Negative n, you move down to the denominator, become x to the power positive n. So this -2, you move down to the denominator, become 2t to the power -2, change to positive 2. And here is -2 is still on the numerator. Always put plus c because c take derivative is 0, so you have to put the c. C means constant. And question 3, 5. So this 5 also factor out. Integral 3 over 2 to the u to the power 3 over 2 du. 5 times, and use power rule again. 3 over 2, add 1, put on denominator. U to the power 3 over 2, add 1, add c. Equal 5. So 3 over 2, add 1, which is 1 over 1, you times 2 both sides. 3 add 2, so 5 over 2, u to the power 5 over 2, plus c. And 5 over 2, reciprocal, become 2 over 5. And 5 with 5 cancel, so you got 2u 5 over 2 plus c. And you can check it. You do derivative. The derivative become 5 over 2 times 2. 2 cancel, get 5. Minus 1. 5 over 2 minus 1 is get 3 over 2. You go back to 5u 3 over 2. You can check backward to check. And next one, question 4. It's 1 over 4x cubed dx equal to, first of all, factor out 1 over 4. And the x cubed move up, become x to the power -3 dx, move up. Then 5 times 1 quarter, integral x -3 dx. Then -3 add 1, -3 add 1. So you got 1 quarter times x to the power -2. -3 add 1 is -2, add a c. Then time together, 4 times -2 is a -8. And x to the power -2, move down to the denominator, get x squared and plus c. Next one, question 5. This use the sum and the difference. And here has 3 terms. So each term is one function. This constant function. This is a linear function. Degree is 1. This is a quadratic function. Degree is 2. 3 functions. And each function take integral. So 4 take integral to dy. -2 factor out. Integral y dy. Plus 3 factor out. Integral y squared dy. And 4 take integral is just y, because for y, you take derivative is go back to 4. And the 2 is still there, and use power rule, 1 add 1, and y to the power 1 add 1. Add 3, and 2 add 1, and y to the power 2 add 1, add c. So here use this one. The two function you add or subtract, you can do each function take integral. The next one also, each term take integral. 0.4 is scalar, factor out, times x cubed, take integral is 3 plus 1, x to the power 3 plus 1 over 3 plus 1, plus 0.03 times x squared, take integral is x to the power 3 over 3, plus 2 times x take integral is x squared over 2. And now you simplify it. 0.4 over 4 cancel, get 0.1 x to the power 4. 0.03 cancel 3, get 0.01 x cubed. And 2 cancel, get x squared per c. And this e take integral. Because e function, e to the power x, take derivative is e to the power x. So e to the power x take integral is still e to the power x. So constant 4 take integral is 4x, because 4x take derivative is go back to 4. So it's 4x. Minus 3, e to the power x take integral is still e to the power x per c. You can check it. You can do this, take derivative is go back to this. ln, here, integral of 1 over u du equal ln absolute value of u plus c. Here need to be put absolute value, because ln function here, this we call argument, that need to be positive. You will not be negative, because logarithm function, this part has to be positive number. You cannot be 0. You cannot be negative. So we put guarantee 1 to be positive, so we put absolute value. So this negative 2 is a scalar, factor out, become integral 1 over u du. And 1 over u take integral is ln absolute value u plus c. Question 9. Integral x to the power 5 plus x squared minus x over x cubed dx. So each one divided by x cubed. Cancel. X to the power 5 over x cubed. 5 minus 3, get x squared. X squared, x cubed. Cancel x squared, get 1 over x minus x over x cubed. Cancel 1x, become 1 over x squared. Then integral x squared plus 1 over x. This 1 over x squared you can switch up, become x to the power negative 2 dx. And then each one take integral. X squared take integral, become x to the power 2 plus 1 over 2 plus 1, plus 1 over x take integral is ln absolute value x minus x to the power negative 2 take integral is negative 2 add 1. On the numerator is x to the power negative 2 add 1 plus c. Then you simplify. 2 plus 1 is 3, and 2 plus 1 is 3. ln absolute value x minus negative 2 add 1 is negative 1, and x to the power negative 1. And then this is not final answer yet. Final answer, we need to change this negative 1, go positive 1. So we switch down to the denominator, become x to the power 1, and 1 over x to the power 1 over x. Negative times negative become plus c. And this one, negative 1 over x, you can factor out. And then integral 1 over x dx. And integral 1 over x is ln absolute value x times the scalar, negative 1/3, and plus c. And the next one, integral, next one we are going to learn is use integral by substitution. by sub, u sub. Now, first of all, you can look at this. This is 2x cubed. You take derivative is going to be 2 times 3 is 6. x3 minus 1, x squared. This take derivative. 5 take derivative is 0. So this take derivative is going to be 6x squared. So we use u sub. How to do u sub? First of all, you let question 11. First of all, you let u equal 2x cubed plus 5. Then you take derivative. du equal du dx. Take derivative to the x. Du dx equals 2 times 3 is 6. X to the power 3 minus 1, 2. Add 5, take derivative is 0. And so this is a 6x squared. And then du over dx times dx become du. Cancel dx. And right side times dx becomes 6x squared dx. And you look at this one. And question here is integral. Then I switch the 2 is 2s cubed plus 5 cubed 6x squared dx times 6x squared dx. I exchange community property. You change order. This part, just du, substitute in. And this part, just u. And that's become integral u cubed. This is let equal u. And this take derivative, get du equal 6x squared dx. So substitute by du. So question become this. And then use power rule. So it's going to be 3 add 1 u, 3 add 1 plus c. And that is going to be 4u to the power 4 plus c. Then substitute u back. What is u? U assume is this. 2s cubed plus 5. So u is 2s cubed plus 5. Substitute back in. To the u is substitute back in plus c. That is the answer. You can take derivative to check it. If you take derivative, it's going to go back to original problem, to this part. So let's do one more time. Let u equal to s cubed plus 5. Then du dx. Take derivative to the u to the x to the x. Take derivative of u to the x is du over dx. Is equal to 2 times 3 x to the power 3 minus 1. 5 take derivative is 0. That is 6x squared. And times both sides by dx. Left side times dx cancel, get du equal 6x squared. Right side times dx, so get 6x squared dx. And the original problem this, you switch. You can see it, how to substitute. Because by communicated properties, multiplication, you can change the order. So put this cube first, then 6x squared dx. 6x squared dx, substitute by du. 2x cubed plus 5, substitute by u. And so got u cubed du. Then now you can use the power rule. 3 plus 1 and u 3 plus 1 plus c. So get 4 and u to the power 4 over 4 plus c. U use original 2x cubed plus 5, substitute back in, and get that's the final answer. You can go back to check this, take derivative by the power rule and the chain rule. Take derivative is 4 go from 4 cancel minus 1, get 2x cubed plus 5 to the power 3. by the chain rule, the inner function take derivative is 6x squared dx. Take derivative, go back to original. So that's antiderivative. Integral is antiderivative. Question 12. Integral of this. Also, we do integration by substitution. U sub. We let u equal x to the power 4 minus 1 because if I take derivative, I got s cubed. I can get s cubed dx. Then I can substitute. So take derivative du. 4 go from 4 minus 1 x, and 1 take derivative is 0. So the du over dx is a 4s cubed. Both sides times dx, so you got du equal 4s cubed dx. And here we want is s cubed dx. So I divided by 4 both sides. I got s cubed dx is equal 1 over 4 du. Now do substitution. Original problem integral. This radical change become 1 over 2. 1 over 2 because here parenthesis 1 and square root is 2. So it's a 1 over 2, m over n. The base is, this is the base, m over n, 1 over 2. Now, x to the power 4 minus 1, substitute by u. Got u to the power 1 over 2. S cubed dx, substitute by 1 over 4 du. And the 1 over 4 go from integral and u 1/2 switch up, become u negative 1 over 2. And this use power rule to do. So we'll get 1/4 times negative 1/2 add 1 and u negative 1/2 add 1 per c. Simplify it. 1/4 times negative 1/2 add 1 is 1/2 u to the power 1/2 per c. So then this 1/2 reciprocal become 2 over 1. 2 with 4 cancel. So you got 1 over 2, and this square root of 1 over 2 change radical because here 1 over 2. So you change to radical is square root of u per c. So you got the not 2 times 1 is 2. U substitute back because u is x to the power 4 minus 1, substitute back. So it's the square root of x to the power 4 minus 1 per c. You can take derivative on this. You will go back to this. So question 13. Also, you can look at this denominator. If you take derivative for denominator, you got 4s cubed plus 7. You got this dx. So you let u equal x to the power 4 plus 7x. Take derivative, become 4x cubed. So get du equal 4s cubed plus 7 dx, which is the numerator part. So then you substitute. Denominate this, substitute by u, got u to the power 4. Numerate this is du. Then move this u to the power 4 up, become u to the power negative 4 du. And then use power rule. Negative 4 add 1, negative 4 add 1. So get u to the power negative 3 over negative 3 plus c. Then switch down. Get negative 1 over 3 u to the power 3 plus c. And substitute back in. U is x to the power 4 plus 7x. Substitute into u back. And you get this answer. So this we call integral by substitution. Also, this one also. You observe this part. T to the power 5 plus 3. If you take derivative, you got 5t to the power 4, which is this part. So you do substitution by substitution. U sub. So let u equal t to the power 5 plus 3. du, take derivative is 5 go from t to the power 5 minus 1 t to the power 4 dt. So, and then this question, and this is the base integral. This one is the base, t to the power 5 plus 3, m over n, 5 over 2, 5 over 2. So here, square root is 2 here. Get 5 over 2. Change from radical to exponential form. And I commutative properties, exchange the two order, and become put 5 t to the power 4 dt. And that part is just du. So this substitute by du. And t to the power 5 plus 3 is a substitute by u. Got u to the power 5 over 2 du. Now you can use power rule to do. So it's a 5 over 2 plus 1, and u to the power 5 over 2 plus 1. And the 1 is 1 over 1 times 2, both sides. And get same denominator is 2. 5 plus 2 is 7 over 2. So it's u to the power 7 over 2 plus c. And then reciprocal, 2 over 7. 2 over 7. And u substitute back, t to the power 5 plus 3, substitute back, 7 over 2 plus c. So you leave answer as exponential form, positive exponent. And you don't need to change back to radical form. You can leave answer with positive exponential form. And don't go back to radical. Next question. Question 15. Here, 2 minus x power 4. If you do this take derivative, you will get 4x cubed dx. So you will know it is u sub. U sub. So first of all, you let denominator equal u equal 2 minus x to the power 4. Take derivative. 2 take derivative is 0 minus 4 go from, and 4 minus 1 cube dx. So du equal negative 4x cubed dx. And here we want x cubed dx. So I divided by negative 4 both sides. So you got s cubed dx equal 1 over negative 4 du. Now substitution in. Integral denominator substitute by u, and the s cubed dx substitute by negative 1/4 du. Negative 1/4 you scalar or constant, multiply, factor out, and got integral 1 over u. Integral 1 over u is ln, ln, absolute value of u, take integral. 1 over u, take integral, is ln absolute value of u. In front have negative 1/4, add c. And substitute back, u is 2 minus x to the power 4. Put absolute value, guarantee is positive. Then 16. You observe this denominator, 4x squared minus 5, you take derivative, you got 8x dx. And here's 2x dx. So you will know you can use u sub. So you let u equal 4x squared minus 5. Take derivative, get du equal 4 times 2 is 8x dx. 5 take derivative is 0. And here want 2x dx. So you divide it by 4 both sides. If you divide it by 4, this side got 2x dx. And this side divided by 4 is 1 over 4 du. So the question is 2x dx, denominator is 4x squared minus 5. Substitute in. So u substitute for denominator got u. Numerator 2x dx is 1/4 du. 1/4 du, substitute in. Take an integral, 1/4, factor out, integral of 1 over u du. Integral of 1 over u du is ln u. So equal to 1/4 times ln absolute value of u. Then u sub back. U is 4x squared minus 5. Substitute into u. Go back. So, next one. Next one, Now also do substitution. Now let u equal negative 0.08x, this part, equal u. Then take derivative, du equal negative 0.08 dx. Because x take derivative is negative 0.08 dx. And here just one dx. So I divided by negative 0.08 both sides. Divided by negative 0.08 and get dx. Cancel. And this side divided by negative 0.08. So become 1 over 0.08 du. That's solved for dx because here has only dx. And then now we substitute back in. So integral, original question, negative 0.08x substitute by u. So get e to the power u times. What is dx? Dx is a negative 1 over 0.08 du. And this part is a constant, and you can factor out. Become negative 1 over